So, welcome to this short tutorial for generating Make2Ds and setting up our kind of line styles in Grasshopper. We will very quickly go through the most common tools in Grasshopper to generate Make2D drawings. This can be, of course, used later on for animated drawings or parametrically adaptable drawings. And then we will look at a few tools from the human plugin in order to control our line weights and line colors and line styles more in general. So for the exercise, we will very briefly model some geometry that we can use as a reference in our Grasshopper setup. So we'll just take now for the exercise these two cones, Boolean them, so that we have some kind of more complex geometry, complex but in the sense that we can generate some interesting views out of that. And as a first step, we're going to reference this geometry into Grasshopper and hide it from here. So then the main tool for making Make2Ds is the Make2D component within the Display tab. So we go into the Display tab in the Dimension tab, and there's the command Make2D. And similar to the Rhino command, we have quite a lot of options to set up our Make2D drawing. So first thing is we can connect our geometry in there. There is a component for defining clipping planes. We can prepare ourselves a small XY plane, which we will control in height to have a kind of generative section along the z-axis. So let's set it up to 50. So now we have a plane that will like intersect in some parts these two cones from here to here roughly. And for the beginning now we will just skip this. And then we need the specific view from which we want to take our Make2D. And we can do this by importing into Grasshopper Rhino Make2D view, or we can define our own Make2D parallel view within Grasshopper. So for that we need a view projection. So for this view projection, we will set up a second plane. We will set up, let's say, a point in space, which we can control through a few coordinates. Let's say these two, and in height. And then we will say that the projection plane is essentially normal from the point to the center of our object. You can define it in all different ways depending on like what kind of view you want to generate. This way you could also do turntable animations if you animate this projection plane around the object, for instance. But for now, let's start with a simple example where we simply take the center point of our Boolean object and we generate a vector from our center of the point that we defined with our coordinates and the center point, and then we create a normal plane which starts in our setup point and with the normal vector. So now this is our projection plane. I think the way that the Make2D component works is that our plane actually needs to look the other way. So we will reverse this vector for that purpose, so that now we have an XY projection plane. And within this projection plane, we need to define a frame. So the frame in the curve component tab we can generate a rectangle, and within that rectangle we can define a specific size. So the rectangle component generally asks for a domain. So in the Maths tab, we will use construct domain to draw a relatively large frame that we have a larger cutout for our drawing. You can adjust these values depending on what kind of size you want to have. This is right now relatively large. You can reduce it probably to something like this, a little bit larger for the beginning, just to make sure that the whole object is within our frame. And now this rectangle we can plug in here. It becomes our projection plane. So we actually need not to reverse that. So this is now the correct projection view. And we plug this view into the Make2D component. And the Make2D component can operate in two ways. You can either compute the Make2D separately, as we can do by saying compute. And you can see that it will generate you the Make2D of our object within the world XY plane. Or alternatively, you can set this to automatic. But in this case, if you have this on automatic, you have to bear in mind that if you move your geometry, it will also recompute the Make2D again. In our case, because the object is also defining the view of the Make2D, our camera, like our Make2D projection plane, will also move with the object. But for instance, if I rotate it, it will recalculate the Make2D successively for each iteration. Now, this might be good for animations, or if you have very simple geometries. If you have very complex geometries where each Make2D calculation step might take a long time, I would advise to turn the automatic off, that you simply, every time there is a change in your geometry, that you compute it separately. If you render out an entire animated drawing, which you can have set up a timeline for it to render out over a couple minutes or hours, depending on the complexity, you will just set it up so that when you run the animation, it will run automatically the Make2D component. So while setting up, keep it in the not automatic mode, and then when you render out the animation later, we will set this to automatic so that we will automatically generate the frames. So now let's look a little bit at the output of this Make2D component. As you can see, if we go in our top view and turn off all the other construction elements, we have a line drawing in Grasshopper, and in this line drawing we have a set of different outputs. Primarily we have visible lines, which are all with the V, and hidden lines with the H. Here we have the indexes of each object, if it is a hidden line or a visible line. So it is very easy to control also, or to filter your line types with these index numbers. But generally we can separate the two types of lines that we have and edit them or style them differently. And this is kind of the next step that we're going to do, is we're going to look at how to create different line weights and different line types for our generated Make2D drawings. For that, I will actually switch my display modes to something that is more relating to our drawing. So I will choose a white background, and I will turn off the axis so that we have just a clean white background for our Grasshopper drawing. And as a first step, we can, let's say, turn off our hidden line. So we just have our visible make-to-the geometry. You can see it's quite cleanly generated with the intersections. And we can, as a first step, go to the human plugin tab. And let's start maybe with custom preview line weights. So the preview line weights component has a few inputs that lets you control the final output of or the visibility of these lines. So first we're gonna place the geometry into the geometry component tab. The default color is this kind of pink. We can very quickly change that by going into the input components and the first tab and pick the color swatch. In the color swatch, you can change colors by right-clicking on the color part of the icon, and then you can choose the color that you want. You can change the different hues. You can change saturations, practically like in Photoshop or other graphic software. For our purpose, let's use black now. And we put the color into the shader input tab. So now we will already have black lines. But the black lines are, as you can see, like infinitely thin, or as thin as the screen allows to render them. And now we can add a certain line thickness to this. So the thickness we can have here. Thickness I will set now as a value between 0 and 1. Now if we type in 1, we will have a line weight of 1, but it is still adapted to the particular zoom in that we are. So it scales the thickness of the lines accordingly to our view. If we have, for instance, if we increase the values of the slider to 10, you will see I can increase the line weights by pixel, but it's always an absolute pixel. So if I zoom out, the line thickness stays the same, but of course the kind of impression of the drawing it becomes like very thick lines for drawing this small and very thin lines for drawing this far zoomed in. You can switch this line thickness also to render them according to absolute values, which is the last kind of option that you have here. It asks for a Boolean value, so either opting in for keeping it general, so fixed to your screen pixelation, or going in true, which generates a true thickness of the line, which our value is currently very high, so we would reduce that to something slightly thinner. And here now you can see that when we zoom in, the line thickness actually becomes bigger. So unlike producing drawings in scale for PDF printing or for printing with an inkjet printer, working in Grasshopper and Rhino for animation, for drawing animations, you will most likely work with pixel thicknesses that are depending on the output of your animation, which we will come to later. So I recommend generally to work with absolute values, not absolute values, but with relative values, so fixed pixel values, because then you can very clearly set up 5 pixel line weight and the second set of drawing lines in a thinner line weight. So this is also what we're going to do now. We now defined our visible lines, and now we want to define our hidden lines. So to make it a bit easier, we can quickly copy paste those components and first plug them into the hidden line tab. So now it becomes a little bit illegible, like what is hidden, what is not. The first thing we can do is we can reduce the line weight of the hidden lines so that we see, okay, the hidden lines are now the thin ones that disappear from the visible ones. But typically we would like to have not only continuous lines, but we want to have dashed lines or some kind of different line type that we want to create. So one kind of line type that we can quickly do ourselves, but again, you can actually play around in Grasshopper, like how to generate different types, is by creating a dashed line. Very simply in the end, we take our input curves from H, and we're gonna start editing them slightly. So in the curve component, we will first start subdividing them. We can do this with shatter. So the shatter component needs two things. We need essentially first all the curves, and then we need parameters at which the single elements are going to be split. And because our curves have different lengths, we are going to do this based on, we can do this either by the actual length, or we can do this for each curve individually as a kind of fixed element. So for instance, what we can do is we can use the divide curve component to generate, let's say, 10 divisions. In that sense, we would get dashed lines that sometimes are very dense and sometimes have very large dashes. Or what we can also do is we can divide by length. If we divide by length and we specify a certain length, let's say 10 will be too large, but let's say 2, then all the curves will have the same kind of subdivision. And because the drawing is already flat on a 2D plane, we will get very even subdivisions. So now if we use our parameters at the division points in our shader tool, we of course need to graft the curves, because our outputs in our length subdivision is already sorted into groups, and we need to have the same kind of like data structure in order for the shader tool to work properly. So now we have our individual groups of shattered lines, and the easy way to generate, like to have like just the dashed lines, is to simply erase every other. So we can do this in the set components. We can do cult pattern, which is a tool that essentially takes a data list and deletes every other line that you have in this list. So we use our input for the list, and it currently has a default false, false, true, true pattern. So it currently keeps the first two and then deletes two. We want, because we want to control our dash length with this slider, so we just want a simple true false pattern that will then generate us with a very clear with our like unit 2 line length. And now if we plug these lines into our component that controls the line weight and line thickness and color, we can also flatten this for that purpose. We will have our dashed lines. Now maybe 2 is even too big, we can even cut this down to 1. And so now we have our hidden lines as dashed lines in our drawing. Now, if we want to do different things, like we want to create shades or other fills in Grasshopper, we cannot use really the Make2D tool for that, or not purely work with the geometry that we get out of the Make2D tool. But we can do a certain, we can use a few tricks to generate much more complex or interesting drawings, or use different shaders to make our drawings a bit beyond the typical line drawings. And one very quick trick is, because we already have the geometry and because we set up our viewport through a plane, is for instance to use like insert basically a background behind our 2D drawing geometry as with our 3D geometry. So I will do this in perspective view for a second so that you see what we will do. So we have our Make2D drawing, which is flat on the ground, and I will quickly turn on our geometry again, and our plane, like our view plane from which we are actually currently doing our Make2D drawing. And So here we have our view that is currently projecting onto the ground. And as we have shown in the previous tutorial on the transform tools, we will use one of those transform tools to essentially move this geometry right underneath this drawing, so that we can edit the kind of visibility style of this geometry as a kind of background underneath our drawing. And for that, we go into the Transform tab. We pick in the Euclidean transformations the orient component. And here we need our geometry first of all. And now we need kind of the source plane and the final plane onto which it needs to be mapped. And the source plane is our viewport plane, our make-2D viewport plane. So what we will see now is that if I would plug this in directly, it would project it actually upwards, because our plane is the z-axis of our projection plane is pointing towards the object, and our end plane, our target plane, is, as for the make-2D drawing, the world xy space. So currently, with this vector, our space is actually inverted, and in top view, it doesn't really, like it is mirrored currently in this view. So what we need to do is we actually need to generate the plane that has the z-axis in the other direction. For that, we can simply copy-paste our normal vector component, and if we double-click and type reverse, you will have the button for reverse vector. You can also find this component in the vector components at the very right at vector, and here you have reverse vector. So it multiplies the vector by -1. And the input is essentially staying the same as in this component, but the vector we will reverse first before generating our plane. And then we will use this as the starting plane. So it will now move the object underneath our drawing. And if I turn off this geometry for a second and we go into top view, you will see that the geometry will perfectly match our make-2D drawing. Now, currently we have it in our standard red shade, and we will look at now at a few components where we can edit the color and transparency of this shading. But it is kind of nice to see that all the line work, like the hidden lines and the visible lines, are all matching nicely the geometry. And because we're going to render out all our drawings in top view, we don't really care that the geometry is actually in 3D space much lower than our actual drawing. It actually gives us the advantage that the line work will always be on top of the as a visibility on top of the geometry underneath. So how to change the kind of shading and style of our geometry is in the display components. So where we also had our make-2D components, we have different tools for creating different shader previews. We will pick custom preview first. And if we plug in the geometry and hide this, it will already have like a kind of default color. Again, this pink that apparently is the kind of standard color in Grasshopper as a default. And here in the shader, we can do two types of inputs. We can either, as we did with our line weights, we can either define it by simply by color. So if I plug in black, we will get a very dark drawing right now. If I choose something more white, we will have shading modes. So this is also kind of nice that you automatically get some kind of shading. This is also dependent on the type of viewport you're in Rhino. So we're currently in wireframe. If I switch to shading, the kind of visibility of this object already changes. And if I go to rendered, mode, and I correct the color a bit because white is just too whited out, you will see that even in rendered mode, the drawing starts to have certain ambient occlusion effects. So now the rendering is already like a little bit heavier, and maybe we will need to like rotate the geometry a bit, but you can see that it renders out the shading of these objects slightly differently depending on your Rhino viewport. And this is, for instance, the shading viewport where you have more the visibility of a shaded mode in Rhino. But particularly with rendered mode, one can create actually very nicely rendered backgrounds for your drawn objects. So one option is to just use a color in Grasshopper directly, or in the display components, there's another component above the custom preview, which is called create material. And here you have a few more settings for your material. So we will start with, again, with our color that we just picked. But here we have 3 different types of colors that we can input. So we have diffuse color, we have specular and emission, and we have a value for transparency and for shininess. So shininess has a, or let's start maybe with transparency. Transparency is quite straightforward. We have a slider between 1 and 0, through which we can control the actual transparency of our objects. So that's also quite nice that even in the rendered mode, of course, at some point the effects of the ambient occlusions turn off, but I find it kind of nice that this happens very gradually. You can control the overall transparency of your objects. The second element is the shininess, which in the rendered mode doesn't really change much, but particularly when you're in shaded mode, this has a different, it kind of transforms the reflection in your viewport through even in your Grasshopper mode. So it's somehow an additional control, usually not so necessary to edit it all the time. Particularly if you work in rendered mode, this is not necessary at all. But those are like 2 separate values that you can control. And with the specular and the emission colors, you can further edit the final output visibility. So if you go into emission, if you add kind of an emissive color, this will further add or transform the kind of visual outcome of your material. So these are a few more settings that you can set up for your materials, for this kind of quick background fills that you might want to have for certain drawings. But now let's say you want to have a very specific curve of your object, let's say like this curve or another one, highlighted in a hatch mode. As it is really not practical to work with the outputs from the Make2D drawing, we will need to extract the curve from the 3D model first, like from our Grasshopper 3D model here, and do a second Make2D operation in order to use that. The reason is that every time our base geometry is re-evaluated with the Make2D component, the sorting of these elements in the Make2D component changes. So we cannot rely on the list order of elements that is the output here, because sometimes it will generate more lines, sometimes it will generate less lines. And so we cannot say, okay, curve 1 will always be edited like this. So what we're gonna do is we're gonna extract some elements of our 3D model in Grasshopper, and then only do Make2Ds with these elements, and then with that we can further fill them, even create hatches. But we will first start with extracting some elements from here. So we can do this by going into our surface component tab. In the analysis part, we have a component called BRep edges. So within here, if we plug in our geometry, we will first get the kind of outer edges of our geometry generated, currently in the 3D model. And what we can do now, and this is something that where we can be certain that if we pick a certain element, we will always get the same one. We can pick, for instance, from our interior edge curves, one of the circular ones that, for instance, this top head of the cone. So we'll use the list item component, and we will pick one of our curves. Let's see how lucky we are by finding the specific one. So let's take this circle, for instance, and now we can copy paste our make2D component so that we generate automatically, like we have all the other settings already laid out before. So we copy paste this, and we're gonna use this geometry now for computing it. If you compute now, you will see you will automatically have this additional curve here. So in order for us to have maybe a better view of that, we will rotate briefly our geometry slightly upwards, and we generate our two make2D drawings. Alright, hide this. So now we have our circle that we kind of generated separately out here. And the good thing now is that as we have the geometry, we can change the line color, for instance, of this line. If we want this to be a different line, we can change the line weight of it. If you want to have it to be thicker or thinner, if we do it thinner, it will kind of overlay with the other one. And what we can also do is we can create extra surfaces from these curves, usually because they are closed. And then, as we did before with the geometry down here, we can actually turn this off maybe. With the geometry down here, we can copy our setup for that, and we can create our own kind of coloration or style for that cap. So this way you can, in maybe not an extremely controlled way as you would do it in Illustrator, you can control certain fills, certain hatches, and styles for your Rhino drawings. The good thing is that you can animate those now. And this is also the next thing we're going to look at, is how to actually generate an animated drawing out of this. So now, as a last step, we're going to look at slider animation. For this purpose, we will quickly hide this line work maybe, otherwise we keep our style the same. And we have now to make a decision, like what is it actually that we want to animate. I think for the purpose now of the tutorial, we will simply animate our camera viewpoint that generates the make2D drawing. Of course, you can animate the object. It can be any form of transformation or anything that runs in your Grasshopper script that you can animate. But we will very simply do an animation where the z-axis of our camera view is being animated. So first of all, we will need to do set our make2D components that are currently not automatically computing to automatically computing. so that for every frame that we generate, we will get a new computed setup, and we will, for instance, now if we switch to the z-coordinate height at 0, it might calculate for a little bit because it now needs to compute quite a few things. So when we have our animated slider that changes the position and therefore the view, we can see that if we're in position 0, we have one certain view of the object. If we go in position 30, that computes it into a different position. This is all now the make2D and the relocation of our 3D geometry right underneath the make2D. And so now we want to animate this. We have essentially 100 frames that we can animate. This is already like very vertically from the top. But as you can see, it works actually quite smooth, like it's for generating the make2D. If you have a lot of geometry, each iteration might take some time, but for now, this works actually quite well. And so how to animate the slider, how to generate actually the single frames that you later can use for editing a video. So if you right-click on your slider and you go to Animate, you will have a small window popping up that essentially sets up your slider animation. First, we will choose a location where we want to save our single frames. So we will create a new folder on the desktop called Animation. And we will set up a certain file extension structure. So let's call this cones. So each of the files will be called cones 001, 002, etc. And the next thing is we will use the top view. That's important because we have our drawing projected onto top view. And the resolution of our drawing, we can set it up, for instance, as 1080 by 1080. Now here you have to be very careful and you have to preview your line weights in this window. Because for instance, if we set this resolution very high at 2000, you will see that the line weights are suddenly much thinner than they are, for instance, on the screen. Because we keep our line weights, we control them as absolute pixels. The more we zoom in, the thinner the line weights get, and the bigger the resolution, also the thinner the line weights get. So you should always preview your line weights in this viewer, so that you can make sure that you have that they don't become too thin or they don't become too thick. Of course, the resolution of this is also largely depending on the output format you want to have. So if you want to have a standard full HD resolution, you would set this up to 1920 by 1080, but then again you should check what is actually the line weight resolution of your elements. And the last thing before we can run the animation is the frame count. So here we will set up the amount of frames that we want to have. And here important is that this number kind of is kind of important to relate it also to the slider that you're animating. So in our case, we have a slider that goes from 0 to 100. But it also has three values behind the comma that independently of like we can actually generate quite a lot of frames without getting chopped off results. If you have a slider that has no values behind the comma or just a few, you have to be careful that if you set up your frame count very high, it will generate you multiple frames that are identical. So for instance, if you have a slider that is between 0 and 100 but without any values behind the comma, and you have 300 frames, the slider itself can only move in these increments of 1, because if we wouldn't have any commas values behind it, it would only have 101 values, so from 0 to 100. And if you set up then more frames than what the slider can actually set onto, it will simply go to the closest number in between. So in our case, it would actually generate always twice the same frame. If you have values behind the comma, but just let's say one value, it might find a different frame for a different slider position for each frame, but it might look very rugged or chopped off because it will sometimes move very fast and sometimes very slow within the animation. So for animating sliders, always add a few commas behind if you want to have more frames, so that you will always receive a smooth animation and not something chopped off. The frame count also relates, of course, to the output format you want to have. So if you plan an animation, you need to know what is the amount of frames per second that you want to have, and how many seconds, or what is the length of your animation. So typically we use 30 frames per second. That's kind of a standard that creates a very smooth image, like sequence of images. But you can go down to 24, for instance, if your frames generate very slowly, similar to rendering out an animation, you can reduce the frame rate to let's say 24, so that you have to generate less frames for the same animation. Be aware that if you go below 24, you will actually start to see that those are single frames. It will look more like a stop motion animation rather than a smooth animation. And so in our case, we will actually just do this video, let's say, for 3 seconds, and we will choose an animation length, a frame rate of 30, so we will do 90 frames. We have a slider with 100 values, but with potentially 100,000 values, because we have 3 values behind the comma. So we set up a folder, we set up our name, and now if we click OK, the animation will start and it will simply render out each frame successively. Depending on how heavy your geometry is, this sometimes might take longer, sometimes it goes faster. Be aware that if you have a lot of geometry and a lot of detailing, that the make-to-these can take their time.